Quantum numbers. Quantum chemistry treats the electron as a wave rather than a particle. And we're actually interested more in the energy of the electron rather than the velocity or position. Okay, so there are these things called orbitals, not to be confused with orbits. Orbitals are basically electron clouds. They are regions of probability where you're going to find that electron. This probability is all mathematically based, so this is the wave functions, etc., that Schrödinger put forth. So this is figure 3.13 from your textbook, and this is what an electron cloud for the hydrogen atom looks like. So figure A shows the electron density. This is the cloud. Where it's darker is where you're most likely to find the electrons. So as you move further away from the nucleus, you actually have less of a chance of finding it. So basically, this is what we call an orbital. So the ground state for any electron is the lowest possible energy for that electron. It is the most stable state, and it can absorb energy at this level and move to a higher energy level, and at that point it becomes excited. So you're either in the ground state on the energy level where you're most stable, or you're excited, you've been bumped to a higher energy level because you've absorbed some energy. So electrons are characterized by a set of 4 numbers. And these are called the quantum numbers. The first 3 numbers describe explicitly which orbital the electrons are found in, and the first 2 by themselves identify the type of orbital. All four numbers identify the electron. You're going to be responsible to know the first two numbers for the types of orbitals and all four for the electrons, but you won't have to identify the specific orbital. So these four quantum numbers are rules. So the first one is called the principal quantum number. The principal quantum number. It has the symbol n, lowercase n, and it is a whole positive number. It specifies the energy level of an atomic orbital. So the higher the number, the higher the energy level. And it also specifies the size of the orbital. As you increase your energy level, the size of the orbital increases as well. So n is a whole positive number, so it's 1, 2, or 3, and theoretically can go to infinity. For every value of n, so for every principal quantum number, there are n shapes or types of orbitals. For example, if n equals 1, there's one type of orbital. For n equals 2, there are two types of orbitals. So on the first energy level, there's only one type of orbital, and as you move further out from the nucleus to the second energy level, there's two types of orbitals. Also, for every value of n, so for every principal quantum number, there are n squared actual orbitals. That can hold a total of 2n squared electrons. So each orbital can hold 2 electrons. That's very important, that one orbital can hold a maximum of 2 electrons. So if n equals 1, there's one type of orbital, and there is n squared, which is 1 squared, actual orbital. So on the first energy level, there's only one actual orbital, and it can hold 2 electrons. N equals 2, the second energy level. There's 2 types of orbitals. N squared is 4, so now there's 4 actual orbitals. So there's 2 types. There's 4 of them, and they can hold 8 electrons. So you can have up to 8 electrons in those orbitals on the second energy level. Okay, so let's summarize this. So we have our principal quantum number, how many types of orbitals, how many actual orbitals, and the maximum number of electrons. So principal quantum number 1 is the lowest we can have. So there's n types of orbitals, there's n squared actual orbitals, and there's 2n squared electrons. So this is n. There's n types of orbitals, there's n squared actual, and 2n squared for electrons. So if our principal quantum number is 2, there's 2 types of orbitals. There's 2 squared, so 4 actual orbitals, and 8 electrons. For n equals 3, the third principal quantum number, there are 3 types of orbitals. So there's 9 actual orbitals, and you can hold a total of 18 electrons. So as n increases, the energy also increases. So n equals 1 is the lowest energy level. N equals 2 is higher in energy than the n equals 1. Therefore, its electrons have more energy as well. As n increases, the probability of finding an electron further from the nucleus increases as the boundary of that orbital is further out. The second quantum number is called the secondary quantum number. And its symbol is L. This indicates, this quantum number indicates the shape of the orbital. The shape of the orbital. and it has allowed values of 0, 1, 2, and up to n minus 1. So its highest value is 1 minus then the highest principal quantum number. So we have names of shapes. If L equals 0, we call it an s orbital. If L equals 1, we call it a p orbital. L equals 2, we call it a d orbital. L equals 3, it's an f orbital. And if L equals 4, we call it a g orbital. These do not mean that the shape is actually an S, a P, a D, or an F, or a G. That's just the names. As the principal quantum number increases, the size of L will increase as well. So if n equals 1, the only value that L can be is 0, because it cannot be higher than n minus 1. 1 minus 1 is 0. So the shape of this orbital is actually a sphere, and this is called the 1s orbital. The 1 comes from the n value, the s comes from the L value. If n equals 2 and L equals 0, for n equals 2 you can have L equals 0 or L equals 1, because that is the upper limit for the values. But if n is 2 and L is 0, you have a larger sphere, and this is called the 2s orbital. The 2 is your n value, and the s comes from your L value. So if n equals 3 and L equals 0, you would have an even larger sphere, and that would be called the 3s orbital. All right, finding out what our L values are. If n equals 1, L has to equal 0, because L values go from 0 all the way up to n minus 1. If n equals 2, L can either be 0 or L can be 1. There's two possibilities. Remember, n is our types of orbitals. There's two types of orbitals. We've got an L equals 0 and our L equals 1. So we have two types of orbitals. We've got s orbitals and we have p orbitals. For n equals 3, L can be 0, L can be 1, or L can be 2. So n equals 3, three possible types of orbitals. So we can have an s, a p, and d orbitals. So the possibilities are, on the first energy level, you can have a 1s orbital. Second energy level, you get 2s and 2p orbitals. And on the third energy level, you get 3s, 3p, and 3d. The third quantum number, or rule, is called the magnetic quantum number. And its symbol is M with a subscript L. This is the spatial orientation of orbitals in three-dimensional space. So along the X, Y, and Z axes. And it was noticed when a magnetic field was applied. The allowed values are from negative L through 0 up to positive L. So, if N equals 1, L equals 0, ML goes from negative L to positive L, where our L value is 0, so our ML value is 0. If N equals 2, L is equal to 0, or L is equal to 1. If L is 0, ML also has to be 0. But for L equals 1, our ML value goes from negative 1 through 0 to plus 1. So if L equals 1, there are 3 possible orbitals. If N equals 3, L is 0, L is 1, or L is 2. So there's 3 types of orbitals. So our ML is 0 if L is 0. Our ML is negative 1, 0, 1 if L is 1. And our ML values for L equals 2 range from negative 2 to positive 2. So there's 5 possible orbitals. If L is 2. There's only 1 possible orbital if L is 0. And there's 3 possible orbitals if L equals 1. So that's telling you that on any energy level, you will have only 1 s orbital. You will have 3 actual p orbitals, and you will have 5 d orbitals. So if you have p orbitals on your energy level, so this is the second energy level or higher, you've actually got 3 possible p orbitals. If you have d orbitals on your energy level, so that's energy level 3 and up, you will have 5 possible d orbitals. So the first 3 quantum numbers actually depict which orbitals you have, as well as identifying the electron. And then the 4th quantum number or rule specifically applies to an electron. It is called the spin quantum number. And it has a symbol m subscript s. And this explains the magnetic properties of atoms. And it refers to just the electrons. In the orbitals. There's only two options. And it's basically a rotation. So you either have a clockwise rotation and your value is plus 1/2, or you have a counterclockwise and your value is negative 1/2. Very important rule here is that no two electrons in an atom can have the same 4 quantum numbers. So no two electrons can have the same 4 quantum numbers in one atom. So if you've got an orbital, they can hold 2 electrons. Let's say this is the 1s electron. So n equals 1, l equals 0, ml equals 0. So all that tells us is that this is a 1s orbital. If you have 2 electrons, one spins up, one spins down. One has an ms value of plus 1/2, and the other one has an ms value of negative 1/2. So they have 4 unique numbers.